All right, so the goal today is to be able to solve equations by elimination where you don't get to start with a common coefficient. So last Friday we learned how to solve by elimination, but all the examples had a common coefficient already present. So all you had to do was just add or subtract them to eliminate one of the variables. Now we're starting where, there's no common coefficients at all, but we still need to use the elimination method. I know you guys like to check your answer using Desmos. I taught you how to do that so that you can, make sure you're doing it right. But if you're on a test, like on paper, which you will have, and it says solve using elimination and you use a different method, you do not get the full points. So I don't want you to get too comfortable with that. You need to be practicing using the elimination method today. All right, but you can solve any system using elimination. It's just sometimes you need to multiply first to get a common coefficient so that one of the variables can eliminate when you add or subtract. So it's kind of like when you used to have to find a common denominator for your fractions. You have to multiply both sides of the fraction by something. It's the same thing, except now it's equations. All right, so that's what we'll be doing today. I'm recording now and I'll make sure to post it in here, but here's some other helpful videos. So tons of resources out there. The practice is a Google form and it is a different practice from the one on Friday. One of them says day 1, the other one says day 2. So just find the link, it's in the slides, also in this assignment link that says day 2. And you click on it, and you'll know if you did it or not, because it only lets you submit it one time. So if you already did it, it won't let you open it again. It'll say you already submitted this form or something like that. So if it lets you see everything, then it's because you still need to do it. There's only 5 problems, so nothing crazy, but you type your answer in, and I get to see what you type in. So if you type in some crap, then I'm not going to give you the points. All right, and you still look like a logical answer, not just something random so that you can get the completion grade. All right, I look at how many you got right, look at what you put. If you put an extra space, it does count it wrong. But luckily, you can see what the answer should have been. So as long as it's the same, if the only thing that's wrong with it is a formatting issue, I'll still give you the points. All right. So just make sure, you know which ones you got wrong and why you got them wrong. So any questions about that? All right, and that'll probably have to be completed outside of class time because we just really don't have time on Mondays. So just make sure you get it done. Preferably before tomorrow, because tomorrow you're going to have an exit ticket. All right. Normally it should be an entrance ticket, but I'm going to push it towards the end because we're doing more stuff with systems. And I think it'd be nice to have that practice before we do the exit ticket. So any questions? So make sure you have the note sheets. They're on the back table. If you don't have them, we're starting here. All right, so previously we learned how to solve systems by adding or subtracting. All right, because there was a common coefficient already in place. Well, what if there's not a common coefficient? So you can still use the elimination method. So I would highlight this part. All right, you can still use the elimination method if we multiply one of the equations by the same value on both sides. So this is by having to multiply first. It says one of the equations. Sometimes you have to multiply both of the equations by something. So one or both of the equations so that you can get a common coefficient. All right, so just like last time, here's an example really broken down. All right, and then after that, it should go a lot quicker. But look at this first system. Are there any common coefficients? So do the x terms have the same number in front of them? Do the y terms? So the answer is no, there's no common coefficient. When each equation is graphed, so we're kind of taking a break from elimination and we graph them, it says that the solution is 1, 1. All right, that is where they intersect. So the solution should be 1, 1. Now, when you multiply both sides of an equation by the same value, is the equation still true? So here's what we're asking. And this is just going to be like a random equation, unrelated to the system right now. But let's say I have 2 plus 2 equals 4.
Can you sign something for Mr. Harvey real quick?
And can you come back to me later?
Yeah.
Yes, thank you. All right, so multiply both sides of the equation by the same thing. Will it still be true? So pick a number. Any number. 7. All right, if I multiply each side by 7, is it still true? All right, so simplify what's in the parentheses. What's 2 plus 2? Good. Equal to 4 times 7. Is that saying the same thing? Yes, and then when we multiply it out, what's 7 times 4? What's 4 times 7? So is this still true? Yes. So that's what we're showing you. That if you multiply both sides, don't just multiply one side, multiply both sides by the same value, yes, the equation is still true. All right, so then scrolling up. To solve using elimination, let's multiply the first equation by 2. All right, so we're taking 2x minus y equals 1, multiplying that whole thing by 2. So what's 2 times 2x? 4x. 2 times negative y. And then 2 times 1, 2. And then by doing that, and also look at your other equation that you had, do I now have a common coefficient? Yes. So you do have to be kind of methodical in what you choose to multiply your equations by. You don't want to multiply it by a number that will still make it not a common coefficient. All right. So looking at it, I know if I multiply it by 2, I get 4. I could have also multiplied the top equation by 4 to get the y term to cancel out. All right, there's different ways you can go about it. No one's going to tell you what to do. All right, you have to be able to figure that out. Any questions so far? All right, so here's my new system. You can solve this using elimination. That's what you learned Friday. So how can I get these to cancel out? Adding or subtracting? Good, just do the ones with the same coefficient have the same sign. Yes, they're both positive. So when it's the same sign, you subtract. What's 4x minus 4x? What is negative 2y minus 4y? Negative 6y. And then 2 minus 8. -6. Do I really need to write the 0? No, because the x term eliminated. So really, this is all we have. So how do you get the y by itself? Good, do that on each side. And what does y equal? Y equals a +1. Good. Am I finished? No, because you still also have to find the x. How do you find x? Good, we're going to substitute y into one of the original equations. Really, it could be from your new system or like the original equation. I say like make your life easier, just pick from the original equations. So which one looks easier? I agree, the top one does look a little easier. So plug in y. Y is now 1. And then how do you get x by itself? Good, add 1 to both sides. I have 2x equals 2. How do you get x by itself? Good. And x equals what? X equals 1. Put that together in coordinate form. And is that the same thing that we got when we graphed it? So we did get the same solution. All right, even though we kind of like manipulated one of the equations, because we did the same thing to both sides of the equation, it doesn't change anything. All right, so we're still on the right track. And then just to prove it even further, if we graphed the new equations that we made, so the one where the x term has a 4 in front of it for both, what's the solution for where they intersect? All right, they also intersect at 1, 1. So it's still the same line. All right, so yes, these also get the same solution. Questions about that? All right, so now that we have like that long-winded explanation, we can go through these examples a little bit. All right, so next page. Here's some step-by-step. If you are one of those people, you like to memorize steps, go ahead. First, figure out which variable you want to eliminate. It can be x or y, whatever looks easier. Then you need to multiply one or both of the equations by a constant. What's a constant? A number, right? A number without a variable. So multiply it by a constant so that adding or subtracting the equations will eliminate the variable. And then solve using the elimination method. So look at example 1a. Do we have common coefficients? No. We do not. What could I do to create one? Good. If I multiply the bottom one by 4, I could get a common coefficient that way. That would cancel out the y. If you wanted to cancel out the x, you would have to multiply both equations by something if you wanted to cancel out the x. So work smarter, not harder. I could just multiply one of the equations by 4 and accomplish the goal of getting a common coefficient. So what's 4 times 2x? Good. 4 times negative 2y. And 4 times negative 10. Good. Do I need to change the top equation at all? No. So I'm just going to rewrite it down here so that I can solve it with elimination. So all I did was rewrite that. But do I have a common coefficient now? Yes. So now we can go ahead and continue with solving by elimination. Questions so far? All right, with adding or subtracting, eliminate the y's. Adding, because they have opposite signs. When they're opposite signs, you add. So what's 8x plus 3x? Negative 8y plus 8y. And negative 40 plus 7. Good. How do you get the x by itself? Divide each side by 11. And what does x equal? Good. All right, am I finished? No, we found the x, we just need y. So how do you find y? Plug it back into one of the original equations. Which one do you want to plug it into? The 2x minus 2y? All right. At the end of the day, it really doesn't matter. But we'll plug it into 2x minus 2y equals negative 10. Remember, now x is negative 3. And we're solving for y. So what's 2 times negative 3? Good, bring everything else down. And solving for y, you have to get rid of what's farther. So how do I cancel out this negative 6? Good. I get negative 2y equals what? And how do you get y by itself? Good. And y equals what? A positive 2. All right, write that in coordinate form. So negative 3, 2 is my answer. That's where the 2 lines intersect, but we're solving using elimination. All right, questions? All right, we're going to start the next one together, and then you'll finish solving it with elimination. So we'll set it up. Any questions about A? All right, so looking at example B, are there any common coefficients? No. Now, looking at it, you don't want to do anything that's like too difficult, right? Like you don't want to make your life harder. So when you're deciding whether you want to get the x term to eliminate or the y term to eliminate, just look at your options. Is there an easy way to get to either one of them? Right? Can I just multiply one of the equations by something? No. I have had students think that they can multiply like the top equation by 6.5, right? Don't do that. Don't make your life hard. Here's a way to do it that I think is pretty easy. So I would eliminate the x term. And the way that I would do that, I would multiply the top one by 4 and the bottom one by 3. And you could do like a negative 3 if you want. You can make it a negative 4 if you want. But that's what I would do. Because isn't it like 4 times 3 and 3 times 4? Won't I get a common coefficient that way? That's what you could do. All right, and then multiply it out. So what is 4 times negative 3x? 4 times 2y. And 4 times 4. I'm going to move this over a little bit. All right, and then bottom one, multiply each one by 3. Don't forget to do it to all the terms. So 3 times 4x is 3 times negative 13y is Good, and 3 times 5 is a positive 15. If you multiply it by -3, then yeah, it's a -15. But up here, I have it as a positive. All right, now when adding or subtracting these two equations together, eliminate the x. Because the way I have it written, adding would eliminate them because they have different signs. So I get 0 for the x term, right? What's 8y plus -39y? Good. And then on the right side, 16 plus 15 is 31. How do you get y by itself? Good. And what does y equal? -1. All right. From there, you guys find x. Got any questions right now? All right. So find x. Give you like 1 minute. All right. So you solve for x by plugging in y. What equation did you plug it into? All right. There is no wrong answer. You can plug it into whichever one you want. If you plug it into the top one, here's what it looks like. So y is now -1. And we're solving for x. So first, what's 2 times -1? Good. And in solving for x, what will you get rid of first? How do I get rid of it? So add 2 to both sides. We got -3x equal to what's 4 plus 2. And opposite of multiplying -3. And x equals -2. So write it in coordinate form. Is it -1, -2, or -2, -1? Good. Always write the x first, even if you solve for y first. Still follow coordinate form. All right, questions. So go ahead and try the next two. So try C and D. For those ones, I will project the answers. So don't just wait for me to do them, because then you only have like a couple minutes to copy them over. So try C and D. I'll project the answers when I think you guys are ready. So when you are ready to go over them, take out your Chromebook and open up the Google Form. That's when I'll know you're ready. 1 second. So for example C, I didn't tell you what you need to multiply by. That's something you guys need to figure out. So just kind of see like what would be easier to get a common coefficient. If you chose to eliminate the x term, you would have had to multiply the top one by 2 and the bottom one by 3. But it is easier just to multiply one of the equations by something, right? So if you can do that, then do that. You can do that to eliminate the y's. If you multiply the bottom one by 4, you see? So multiply the bottom one by 4, you get 8x plus 4y equals -32. Pair that up with the top equation and solve by elimination. All right, the way that I set it up, I would need to subtract the equations to eliminate the y's because the y's had the same sign. All right, so that's what we did. Solve for x, plug it back in, solve for y, and that's how we get our final answer. All right, same thing over here, except this time you had no choice but to multiply both equations by something. You could have multiplied the top one by 5 and the bottom one by 2 to eliminate x, or you can multiply the top one by 2 and the bottom one by 3 to eliminate y. All right, you have to multiply both equations this time, and then solve using elimination. Any any questions? All right, so complete your practice at home. It's only 5 problems. Try to get it done before tomorrow, so that way you're ready for your exit ticket.